Good afternoon, everyone, and welcome to another Big Data London webinar. This time we're centering on graph analytics. I'm Andy Steed. I'm Content Director of Big Data London, and today I'm joined by Richard Henderson. Hello, Richard. Martin Darling. Hello. And Hi. Mike Bugembe. Hi. Hi. So these sessions, as always, are designed to be interactive, so please send in your questions during the presentations. We're doing a slightly different format today, where we're going back to back with the two presentations, and then we're doing an extended Q&A where we'll discuss some of the points raised, and we'll obviously answer all your questions. So without further ado, I'd like to pass on to our first presenter. Over to you, Richard.
Thank you very much. Okay, I'm going to see if I can work this. Of course, it worked 5 minutes ago. Hopefully you can see my screen. Okay, I'll assume that's a yes. So what I was asked.
No, that's a no. Try again.
Let me try again. I'll get there eventually.
There we go. It's promising.
There we go. How's that?
That's good.
Perfect.
Fantastic. So what I was asked to do was, since graph is really started becoming a bit of there's quite a lot of noise around at the moment, was just to go through some of the reasons why people use graph. Now I'm using the word use cases in an extremely generous sense. So this is a combination of business use cases and also the more technical ways in which graph databases are used, specifically TigerGraph. So I've been working for TigerGraph for a couple of years. TigerGraph's been around for about 7 or 8 years in total, but only 3 years in the public domain. And our big thing is the ability not only to have a graph database, but to be able to do analytics on top of it. So this is why it's adoption of graph analytics, which is very much the thing that we're interested in. So first slide, first of all, it's not only us who think that this is going to be a big deal. Gartner has been very strong in talking about how graph analytics is something that people should be looking at to get to the next level in terms of their data analytics and big data processing requirements. IDC, it's always nice to get IDC to talk about us, and they make the point, which I think is the case, is the reason why it's a good thing to have is because an awful lot of the intelligence in data actually lies in the relationship of one piece of data to another piece of data. So the individual pieces of data in themselves are all very interesting, but given that the whole is greater than the parts, then the question is, well, what's the difference and how do you find that? And the only way you can really look at that is by looking at the structure and linkages between that data. So Gartner, as I say, is saying the single most effective competitive differentiator for organizations pursuing data-driven operations and decisions after the design of data capture. Marvelous. So that's exactly what we serve, is that market. So the reason, why is it a graph database instead of, what are the sort of things, what are the variety of things that people tend to use? And there's actually quite a number of these, but the ones that we see most often people querying us about, probably because these are the areas where the most value lies, particularly in the retail space, but not just in the retail space, also in fraud and similar space. Things like finding similar users and customers. So this is very much in the graph world, we talk about community detection. This is how do we find people who are similar to other people in a particular way. Now, graph, it's not just about social graph, it's not just about direct links between people, but also how are they indirectly connected? And generally you need some way of hopping 1, 2, 3 hops between a person, thing they like, the features that are associated with that particular thing, other things that have those features and so forth. And so generally, for example, in the purchasing, if you're looking for finding similar customers in terms of what they purchase, you need to think about the customer. You need to know what they purchased. You need to know what sort of thing is it that they purchased? What other items can they buy that have the same features and so forth? So it's not simply a matter of relating people directly. There's also those indirect links, and often we're finding that some of the most useful intelligence actually lies in those indirect links, what we call deep linking. Uncovering hidden connections. So as much as we're good at finding the direct connections, which are there, It's also very important to understand where are the connections that should be there, where are the spaces where there should be a link. And again, graph is a very good way of doing that because it effectively can set the baseline. This is the sort of linkage that you expect to see between items. And therefore, if that linkage doesn't exist between two things when it should, therefore you've found a connection that should be there. And finding that is very, very important, particularly in fraud applications, credit card or transactions fraud. Then looking for those hidden connections is very important. Next best action, recommendation engines. So this is used in many more places than just video buying or buying things on Amazon. Actually, we do recommendation engines for some huge platforms. Wish.com is the largest retail platform in the world. Alibaba, also a massive retail platform. Then their recommendation engines, they need to be not only big, but very, very fast. And so that's something that we tend to do directly with analytics on the database. And that's a very important use case for us. Finding the most influential users and customers is always nice to know who are actually doing good things for you, rather than it always being about fraud. Sometimes it's about finding what is useful. And I think Mike's going to mention that later. But generally, if you're going to concentrate things like advertising spend, marketing, and so forth, you want to know who is the most influential. And you can usually work that out by if you understand a little bit about how people connect with each other, as well as what they are actually purchasing, by looking for the patterns of purchase and then who tends to buy things that they buy. That's a very simple thing to say, but actually quite hard to analyze. And graph databases can really help. And finally, we have detecting connected user and communities. That's really about characterizing a community. So as much as it's not just about finding which customers are similar to other customers, but then saying what characterizes those, what's their demographic. And that allows you to make sure that you're offering them the correct products, but also allows you to understand just what marketing you should be doing to those people. How do people actually do it? We find there's three simple steps that go from not ever having dealt with graph databases or not having actually dealt with linked data before, and how do you actually move to the point where you're getting value out of it. And we work really hard to make that as easy as possible. But the first point is the thing we talk about is entity resolution, which is sometimes described as a graph use case. If generally you're going to start with data sets where you have the information, it just isn't linked together yet. And so the first thing you have to be able to do is to be able to link that data. And this is, in the business, is called entity resolution. And the idea is that you should be able to identify individuals or be able to correlate data between these different data sets. And sometimes that's very easy, but sometimes it's a little bit harder. So email addresses generally are really easy if you want to identify single users. But if they give a name, then quite potentially it could have been written in different ways: first name, last name, first name. It could have been misspelled. At that point, you need to get into slightly fuzzier ways of doing it. Unfortunately, graph, because it has access to all the data available, can score the likelihood of two entities being the same. And in this case, an entity is just a generic word. It could be a person, it could be a thing, it could be a place, it could be anything which you want to model inside your database. Second step at that point is to then analyze those relationships, which is all those things that we talked about earlier. And the sort of data that you're generally analyzing are a combination of things like marketing campaigns. So what actually have you put out into the world, hoping to get people to buy stuff? Viewership history, if you're looking at media streaming and media, who has watched what? Promotional responses, engagement activity. You can see there's a whole load of stuff. So some of this will be static data, which is relating to what you know about your individual customers already. But a lot of it is more dynamic event data, which you want to hang on to it as it goes through. And this is when you start getting this idea of having a very responsive way of dealing with those analytics. So we're not just talking about batch analysis, overnight analysis. We're also talking about continuously updated models so that you can continuously react to the individual situations. And one of the resulting use cases we're going to talk about later is recommendation engine and how that becomes personalized when you use a graph database. And finally, once you've done the analysis so that you can understand exactly what's going on within your data sets, then at that point you move on to the next more strategic analytics of your database, which is this idea of insights and actions. So, okay, so I've identified all of the data, I've put it all together, I now know how the data links together, and indeed I can feed it with the events that I want. Now you want to be able to use it for something useful. And this is the point where you need to find similar users and customers. So for example, for recommendation engines, it's very important to find similar users and customers as quickly as possible, particularly if you've got a brand new customer. There's a thing called the cold start problem, where if you do not have any history for a customer, then you have to find some other way to decide how you're going to recommend products to them when they want to have a recommendation. And the best way to do that at the moment is to try and find who that customer is similar to and then recommend similar things. At that point, you can then adjust after the point, but that gives you a starting point. Uncovering hidden connections. We have people use this a lot for things like anti-money laundering, particularly, where people will tend to try and hide the fact that they are related. Usually, people, if you are interacting with bad guys, you don't want to yourself be seen as being connected to those bad guys for very obvious reasons. So uncovering those hidden connections in the way that we talked about earlier is a very important part of the anti-money laundering problem. Recommended next best action is really just the same as recommendation engine, but applied to, say, customer experience. Influential customers, we've talked about who is it that has the most influence in any particular campaign for marketing. And finally, finding those communities we talked about as well. Is this, once you can start gathering people into communities, finding out people who have similar likes and dislikes, then at that point you can start saying something quite reasonable about the entire market. You can actually start saying something about the way they interact. This is used not only in the retail space, but it's also used for things like looking for fraud syndicates is a very common problem in credit card fraud. And so detecting connected users and communities allows you to very rapidly shut down entire syndicates who are doing bad things. So moving on. Right, let's get into the first use case. So we talked about entity resolution, and this is a deliberately simplistic picture. The idea is to work out if two technical identities, which are identities in the database, are actually the same physical identity. And the reason I made this picture quite simple was to point out that in graph world, if you look at it, it actually doesn't look that difficult. In tabular data world, it's actually a lot harder to do this. But in graph world, effectively what you're looking for is how many shared points of information do we have between these two technical identities. And if there are a large number of shared points, then it's quite possible they're the same person. And so you just put a link between them, which is this big red bar. Similarly, and as you can see, the two people who are linked on the left share a number of items, but they don't share so many items with the other people in the graph. And similarly on the right, you have two people who have shared an awful lot of information, and so therefore they're likely to be linked. The link itself, we don't have to remove any data. All we have to do is add that one edge in order to illustrate the fact that there is a linkage between those people, and that linkage can change over time as we get more information, which allows us to have a very dynamic view of what the actual physical situation is. If we look at it a little bit more technically, Customer 360 it talks about here is something that is very commonly applied. Here we can see a very simple but actually representative case where we have three sources of information. We map that information into the graph database, and at least initially we have what are apparently two identities, and these are our technical identities. But because we can see that they share a social security number, it's actually a very good candidate for merging those identities. And as we can see, we end up with a single user on the right. Now, that's a single logical user on the right, but the physical information associated with that, which appears on the left, that can still be in the graph. So you never actually lose that information. You're merely adding to the information in order to say, this is what I think, this is how I understand this information. Moving quickly on to use case number 2. fraud detection. So this shows a picture of the way that payments often move around a network. If you've only got a relational database, then you'll usually only have the information on the left, which is linked up in any tangible way. So that's the user and all the things that that user does. So the things that are directly linked to that user, his phone numbers, his devices, his accounts, credit cards, and so on. And since you only have a very narrow amount of information, only that direct information, that fundamentally limits the amount of intelligence that you can get based on that information. If I go to the next, with a graph database, it's much easier to add extra hops. So this idea of deep linkage, finding information that's linked across the network of interactions. And here what we're seeing is that it's not until you get to 6 or 7 hops out on the right that you see that there is actually a relationship to another user who was previously involved in fraud cases. And that allows you to really get a much better view of risk associated with any particular activity associated with a user. And that can improve your fraud detection, avoiding false positives as well as false negatives. In such a way, we're seeing a reasonable percentage improvement in fraud detection over current existing means. And given that we're talking hundreds of billions of dollars here, any small percentages actually translates into a large amount of money. Explainable AI and ML. So one of the important things is if you're going to start making decisions about whether somebody's allowed to buy something or not buy something, it's very important that you can explain that decision. Now, when you have a lot more features, because you're looking at this extended context around information, then it means that you can use simpler ways of using machine learning in order to decision or to explain things. So we have customers who started off using things like neural networks and deep learning, which was fantastic. But the difficulty is it's very difficult to explain or justify the decisions that come out of the back of that. Instead, what they found was that by using a much broader number of features associated with it, they could use simple decision trees or random forests and similar techniques, which are intrinsically much easier to explain and so therefore to justify. And in this particular instance, our customer was using it for trying to find doctors who were essentially ripping off the insurers. This is in America. They're ripping off insurers by making them buy really expensive drugs or giving out prescriptions for opioids inappropriately, which is very pertinent right now. But in order to do that, they had to, if they were going to go to court and say this person is a bad guy, they had to have this explainability. Just to show you, this is what the real rules are that came out of this. By having this extended information, they found that there were 2 or 3 elements actually gave a very good indication of whether there was a problem or not. And so they went from having something which had a huge amount of complexity and was very black box to something where they could very easily explain why it is that the doctor was a good doctor or a bad doctor. In this particular case, they showed that it was doctors essentially tried to cover their tracks by creating a diversity, which actually wasn't appropriate. That diversity didn't happen if it was a normal doctor. Normal doctors tended to prescribe the same things to the same people using the same pharmacies, whereas doctors who were doing bad things did not have that characteristic. Personal recommendations is the last one. The interesting thing about this is personalization. So I've already talked about how if you've got a brand new customer, it's really hard to know what to recommend to them. If you've got a brand new product, it's very difficult to know what to recommend to them. And also, there's no point in giving people the product they just bought 5 minutes ago. You need you need to be able to evolve your recommendations during a single session with the user. So in this particular case, you need to deal with not only similar people and similar products, but you also need to deal with similar context and similar location. And that's, with a graph, it's very easy to integrate these real-time pieces of information, including real-time history, so that you've actually got a dynamic recommendation approach. One customer who uses this for this is IPPEN Digital in Germany. They are having tremendous success in hard copy media, and they're almost unique in this. Generally, hard copy media is considered to be a dying industry. Well, Mr. IPPEN in Germany has proven that it isn't. That the way you do it is by not just doing blanket advertising anymore, but doing audience-driven recommendation, which is actually invited by the user. And so here they're using their 360-degree view of customer interests and preferences, which they know from their digital interactions, but also using TigerGraph as a knowledge graph in order to effectively guarantee that when they're making recommendations or putting advertising in front of people, it's actually something that they want to see. And they're finding that if they do this well enough, that people actually prefer to come back to the sites because of the recommendations, which is kind of the opposite of what you expect. Usually people are put off by too much advertising. What Mr. IPPEN has shown is that if the advertising is good and relevant enough, and he's recommending articles as well as products, then you end up creating this very virtuous, personalized approach. And that's the end of this slideshow. So hopefully that was interesting. I'm going to, if I can work this, I'm going to stop sharing and I'm going to go over to Mike Bugembe. Go for it, Mike.
Yeah. So thanks very much, Richard. Just before I introduce Mike, I thought it might be worthwhile. We've had a couple of questions asking for the slides, so I thought I'd just mention the fact that directly after this webinar broadcast, this will be available on demand almost immediately, so you can go back in, watch parts of the presentation that you want to go over again, perhaps, and I'm sure Richard will make his slides available as well. In the bottom left-hand corner, there's some links, attachments, they're called, in the bottom left-hand corner of your screen. If you go into there, there's some links from TigerGraph supporting the information that's just come, and some information about some upcoming webinars we've got. So anyway, enough from me. Delighted to pass over to Mike Bugembe. Thanks, Mike.
Great, thank you. I'm now hoping that you can see my screen as I share.
Yes, all good, Mike.
Okay, excellent. So, afternoon all. The topic for this particular presentation is why you can have the best data science team in the world, and even some of the technologies that we've just seen, for example, and it just isn't enough to even get some of the amazing capabilities into production. So a quick introduction to myself very quickly. I used to be the Chief Analytics Officer at JustGiving, and I left in 2017 when we sold the company. We used a whole host of AI and algorithms there to really try and help increase generosity and grow the world of giving, and got the company a valuation of over 100 million. On the back of that and some of the difficulties that I had, I wrote the book Cracking the Data Code in 2018, and that's done pretty well in Amazon. Really, it's a book for executives, for them to really understand the role that they play in making sure that they can get AI and data to work for them. And I'm now a founder of a company called Lense.AI, and we do non-technical training for execs and managers in the full spectrum of data. So we cover data literacy all the way down to AI for execs, and even those who are seeking career changes. But as we've just talked about graph, I thought it would be relevant for me to just share a little bit about JustGiving. So what you saw here, this is, we had the opportunity to also use some graph technology, so I thought this would be a good use case to add. And this is a snapshot of what the world of giving, a machine view, looking at each individual who's donated as a node, and the relationship between a fundraiser and a sponsor or somebody who's giving to that page, in the same way that a lot of us may have given to, I think it's Captain Tom's page. You would appear in the JustGiving graph somewhere like this. There's charities in there as well. But it was a great opportunity for us because in order for us to be, try and transform the giving space, we really had to look at connections between people. And looking at our data as a graph, so this is the exact same data that we would normally have in tabular format, but moving it into a graph format allowed us to make a range of calculations. So for example, if you've read the book Tipping Point by Malcolm Gladwell, one of the earlier chapters, he talks about how things go viral. Our graph allowed us to make calculations, between us calculations with against individuals, so that we can see who perhaps is really good at influencing others to either fundraise or to donate, who just does it because actually they have deep technical knowledge and they love doing it for a particular charity, and who are the people that have massive networks and how information and sentiment goes through those networks. So it was an exciting time to use some of that tech. But actually, we're not here to talk about that. We're here to talk about why a data science team is not enough. And I think this is a good example because this also shows how only a portion of this functionality made it into production. And you can see there was so much more we could do with it. We could see who should donate to your page. And the moment that this person donates to your page, another 20 will come to donate. But whilst we had that capability within the data science team, getting that into production was not so easy. So, of course, we all have the envy of organizations like these who are able to get their data science ideas into production and, see some, transformative value from that. So Facebook, I think in Q4 2019, we're doing in excess of 21 billion, Google 46 billion. A lot of that is data and AI driven. Amazon for the same quarter, I think did 87 billion, but only a portion of that we can give to the recommendation engine. The problem with using these examples is that it makes it appear that success in data and AI is really left to the large tech organizations. So I like to look at other examples to show that, look, it's possible for all of us. Two examples I can give real quickly is Walmart and also Morrison's. It's been said that there's potentially around a £340 billion prize, or $1 billion prize, I think the number was, if AI was deployed more successfully within this retail sector. And Walmart themselves managed to find in excess of 2 billion optimization savings. And Morrison also managed to reduce, I think, some stock replenishment on shelf gaps by about 30% as well. So that's just really to show that you don't have to be tech to be able to see some of these benefits. But other examples, even in the social space, a company called the Black Dog Institute on the left, they used AI to try and predict who is likely to suffer from mental illness or depression, particularly around soldiers who were returning from Afghanistan after a tour of duty. And very successfully were able to predict who was likely to commit suicide. And rather than wait for it to happen, they could intervene using the data to prescribe what you should do to try and reduce that. Anne Milgram in the middle, she does a really interesting TED talk on how data and analytics really help to reduce crime in the, she was the Attorney General, I think, in Connecticut. I'm not sure, one of the states in the US, and was able to use analytics to reduce crime successfully there. And Catapult, a great organization used by most of the sport teams, they do, they can predict the likelihood of an injury on a player. So do a lot of work around injury prevention, using data to prescribe what exercises to do and so forth. But yeah, some very exciting use cases outside of the tech space. And as we know, even today, it's still expected that data, AI, machine learning is a $1 trillion industry, and it'll happen across every industry sector. It's a great report by, this is a snapshot from a report by McKinsey, where you can see the difference between those who are successful to deploy and those who are unsuccessful. So I think really just to get us to understand that every industry can benefit from this, but it's actually still difficult. And I've seen numbers range from 75% to about 96% of organizations that invest in this stuff fail to see a return on investment, even when they've hired the best PhDs, the most amazing data science teams, and they're still struggling. So I'll give you a little story, some background as to how we went through some of these challenges and also ended up resolving them. A quick example, let's say you come across a marketing team, and in this instance, the use case was, would we be able to send emails to our millions of users and increase their likelihood to come back and make another purchase? Because we found one additional purchase from an individual will result in a massive growth for the organization. And so as typically happens, it's a great idea. Everyone gets excited. First thing they did is they hired an amazing data science team. Now, initially you had promised that you'd be able to have this result within 6 months, but then decided to go out and look for people with a few letters after their names and PhDs and so forth. So we already lost time in that. And despite hiring the team, there was already some time lost in that venture. And then straight away, you get into the data and you find that, look, it's sitting in different places. It's not a priority for IT, for example, to come and resolve. Some of the marketing team haven't captured the emails correctly. There's duplication. It's great. We saw some of the graph use cases there on how to, almost get a single customer view. There's manual coding in there, and already you're 3 months delayed now into the project. This is normal for many people in this space, and hopefully you'll be able to identify with some of these challenges. But let's say you get past all of this, right? And you create an algorithm, and then suddenly you see that the algorithm is only as good as a coin toss, so its prediction is no better than 50% chance. And you need to go back to your teams and explain that actually you probably need to capture some more data. You've got this massive team that's taken up a lot of resources and still failed to get a result. And this really speaks to the experimental nature of AI and data and machine learning. Hopefully I'm preaching to the choir here, but this is so normal that you have to go back to the business and explain that. You lose more time. And then eventually you get the algorithm working and you go out and you celebrate. And this is usually quite an exciting period. However, what seems to happen more often than not is shortly after that, the marketing team goes right back to the traditional ways of doing things. So you've invested all that time, you've actually got your algorithm working. It is 90% better than the approach that they've currently got, and you can empirically show that. But they go back to the traditional way of working. This is just a story to illustrate some of the reason why we see such big failures in an investment in any of this tech. Now, when I was at JustGiving, we were very easily one of those organizations that were, that 75% chance of failing. I've seen the number as high as 98%, really. And what I did is I basically got in touch with everybody that I knew, all of my contacts in Spotify, in Facebook, in pretty much most of the apps that you have on your phone. I managed to find somebody that either I did know or I was going to know very quickly, and try to understand what have they done differently that they can build some fantastic algorithms and get it used and go past all of those data issues and all of that sort of stuff. And they all had some varying opinions on how to do different things. But what emerged really quickly was a very, very clear pattern of behavior. And so what I saw was, I'll tell you the three things that were very distinctly clear with each of those organizations. Firstly, they all had either a chief data officer or a chief analytics officer. And this is somebody who was dedicated to generating value from data, but also sat on a leadership position. So had the feet in both sides of the camp, could speak the business language and really interact with leadership, but also manage that investment. And then, of course, when it came to their hiring of the teams, each one of those, it was really clear, had given up on this notion of hiring that unicorn that can do everything. In fact, what they were doing was hiring for each specific skill. So they had people who were fantastic at manipulating really, really large data sets. And they were separate from the people who were great at writing algorithms, who were also separate from the individuals who were really good at productionizing that into enterprise-grade code. So that's two patterns that were very, very clear. But the number one factor that each of them would testify was the main reason for their success, was that they had a business and a leadership team that actually understood this thing we call data and AI and analytics. It is fundamentally different. When I met many members of their business and their leadership team, you could genuinely see a difference between them and the others, if you like, who had a real understanding of what data could do, how you could use it. In fact, I went in as far as being able to see that each member of their business was put through specific courses. In some of those organizations, any person who joined the organization would spend 2 weeks learning about data, and 1 week was entirely dedicated to understanding how to ask data the right questions, how to read data, how to work with data, and how to reason with data. And this is something that a lot of those organizations who are in the more likely to fail bracket weren't doing, or they didn't have a leadership team and a business team that truly understood how to work with data. If you take it further on the data spectrum from data to AI, you could even see that anytime I asked these were the questions they were all able to answer very, very clearly. They knew what AI really looks like in production. This is great because a lot of leadership teams still have been influenced by Hollywood, A lot of them will face fear. Imagine that marketing team that I was telling you about earlier. The biggest fear was you're bringing a machine that can do my job better, rather than finding ways for us to work together. So that was a real challenge. But they all knew how to find the killer use case, and they understood what it really took to deliver. And this is true for every single one of these organizations. I will highlight that at the time, when I met with people from Netflix, they didn't have a chief data officer. I don't know if they do now, but at that time they didn't. But this was true for every single one of these organizations, that the number one factor was that they had a team, a business team and a leadership team that understood data. What was even fascinating is when McKinsey produced this report to show that all the companies that were succeeding with AI, machine learning, and data, those are the companies in orange. And each of them had a leadership and a business team that were data literate, that knew what AI was and knew how to find the killer use cases. It seems obvious, but it's actually really interesting when they don't understand that, how resistant they will be, excuse me, got the hiccups, to change, and how resistant they will be to even new technology. And just to put that in a bit more context, I had dinner with Gary Kasparov towards the end of last year. And one of the things that he raised during that time, which was really interesting, was he said, would he have been able to beat Deep Blue? For those who don't know, by the way, Gary Kasparov was a chess champion, grandmaster, who was beaten by IBM's Deep Blue in the 90s, I believe. But he asked the question that if he could work closer with AI and data, if he was working with a machine, would he be able to beat Deep Blue? So combining human intelligence plus machine intelligence, which is what these businesses seem to have exhibited. And a few years later, he described a situation where he had that opportunity to see that materialize, where there was an open chess championship where you could either be a grandmaster, you could be an amateur, you could also be, or there were computers in there as well. I think Hydra was part of that, which was the sort of advanced version of Deep Blue. And or you can have any combination or permutation of all of those things. And what was really interesting was the winner of that tournament was an amateur, two amateurs working with 3 Dell machines and 60 quid's worth of software. The difference between those amateurs and the grandmasters, or the grandmasters plus computers, or any of those combinations, was that these guys really had these 3 characteristics. They knew how to take human intuition and combine it with machine calculation. They were able to understand how to strategize and use that creation ability that humans have and combine it with machine tactics. Human experience, and of course, they were very humble and accepted that the machines had better memory. This is what I saw in each of those successful organizations. And for us at JustGiving at that time, the message became really, really, really clear. That in order for some of those amazing capabilities that we can develop, in order for them to see the light of day, hit production, and for data and AI to make these fundamental changes within business, the business teams and leaders had to learn and had to be educated about data. And that's the key thing that we found. And if there's one message that I would really like for you to take away from that, is that look, we can have the best data science team, but often I've seen that that's really, really unsuccessful unless you have a business and a leadership team that pretty much get it. And so that really concludes my presentation. Just a quick slide in saying that we at Lense.AI, we help everyone see and understand data. We run a set of non-technical courses for non-technical people, for execs and managers. And really we help a lot of data science teams just get over that hump by educating their business teams. And also the book covers a lot of those subjects that I've talked about. So feel free to go on Amazon and have a look at it. But this is the end of my presentation. So I'll stop sharing right now. And I think we're ready to take some questions. Is that right, Andy?
Yes, that's right. Yeah. So I've got a couple for you, Mike. I'll come back to in a second. But I want to kick things off with some more questions around the graph stuff that we were having before. I thought I'd bring you into the conversation, Martin, since we haven't heard from you yet, and I think this question might actually sort of fall into your sweet spot. I think rewording this question slightly, what are the reasons that people are adopting this? Why is graph adoption taking off so much? I'm guessing you're talking to clients and stuff quite regularly. So what's some of the reasons that people are telling you?
Oh, thank you. It's a good question. It's probably my favorite question, to be honest with you. Well, the start of any kind of adoption curve is always driven by the fact that it gives a better return on investment than anything else from a technology point of view that you can make at the moment. So what we're seeing is as our customers sort of move beyond big data, they're beginning to realize that with graph, they can answer questions that they couldn't answer before. And that can, if it's done correctly, will give new and unique business insights. And if that delivers new and unique business value, that's what absolutely drives the investments. But as you said, graph is not new. So it showed a lot of promise in its early days, but some of the early products that were out there were slightly limited in terms of the ability to do inbuilt analytics, the ability to be cloud native. There's some questionable performance, and that put people off using some of the graph technologies. But those problems are solved. Obviously, quick commercial plug by companies like TigerGraph, and that's allowed us to move into sort of real-time production integrated analytics workloads, where people can see these new and unique business insights. And in times that we're in now, difficult and challenging times, what is the stuff that's still getting done is something that can be done quickly at relatively low cost, that can drive a significant impact on the bottom line. That's the challenge that all our customers are facing during this time, and that's really where graph delivers.
Okay. And is this the domain of the big company, of the giants? I know it's always the big companies that are held up as the examples, obviously, but is this something for companies of all sizes, or is it?
Well, I mean, there's kind of a two-pronged answer to that. Obviously, it's a data solution, so it's horizontal across all companies. But I think kind of where Mike was alluding to, all the large organizations, I mean, I would view that the main competition for companies like TigerGraph is actually people trying to deploy graph-type workloads on NoSQL or relational databases, and kind of doing it badly is probably the most common thing that we really see in the market. And that, without being rude, is probably what we see more in the big companies. And then there's the period of pain that they have to go through before they realize that maybe they should put it onto the right platform. Whereas we see there's a sort of the digital native community, they will move straight onto graph off the bat. So no, it's not just for big companies. And I think that's the beauty of graph. It can deliver business value for small, medium, or large companies, and without that being a sort of sleazy marketing line. We have customers with 50 employees, and we have customers with hundreds of thousands of employees. So it depends on the business case.
Yeah. Okay. And I'm going to go to you now, Mike, with a question around sort of the management aspect of this. If one of the people who's watching here today is part of a data team who is perhaps not in an enlightened company that you were sort of describing at the end, what can they do? Or have you got maybe one piece of advice of what they can do aside from moving to another company to make their situation better? What do they need to be doing? What do they need to be saying to make their bosses take this seriously, I guess?
You know what? I think the truth is, investing in data and companies like TigerGraph and doing all of that is actually right now about survival. So three things tend to happen when you have new technologies. You have existing companies that adopt it and they stick around, they survive and thrive. New entrants come into play, and then you have a lot of those that sort of ignored it for a little while, disappear, right? But being a data person, trying to tell your executives that is always going to be quite difficult. So there's a big behavioral economics thing at play here. The worst thing you can do is be the one to try and educate them, right? They already have a perception of you, an understanding of what you look like. What we did at JustGiving, and I'm being really frank here, is that we actually paid an external company to do the training that we had put together ourselves. So there's a perception thing sometimes that you're able to get through. Now that requires some humility, because it's not about you. You want to get the tech into production. That's what you're really after. So it's what it takes to get the executives to listen and to understand. Sometimes you need an external party, but you can control that. That's still within your control. So the one big takeaway I would say from that is educate your business, but don't be the one to do it. That's the worst thing to do.
Yeah, cool. Thank you very much. Thank you very much. And there was one question that you might know off the top of your head for this guy who's asked. Do you know the talk title of the TED session you referenced?
I can't remember, but her name is Anne Milgram, and I'm not sure she's done that many, to be honest. So I think it should be quite easy to find. Yeah.
That sounds like you'll be able to find it then. So that's great.
I could just put in a little on that's really interesting about how do you move towards a data-driven approach. Certainly, in my experience, and I've worked at quite a lot of different levels in an organization, and one of the things that is clearly a concern, and this is at all scales within a company, and also when you're a technology company trying to sell technology, is never sell technology. Trying to sell technology is a hiding to nothing, because people don't care. They have no interest. The people who live and die by in business are not living and dying because of their technology. They're living and dying because of whether they're getting the right information at the right time that allows them to make the right decisions. So definitely addressing the value proposition, addressing the things that they care about is key. And then you work backwards from there to the technology. This is a huge learning point for us as trying to sell technology into organizations. Is we generally try not to go in and sell the technology. We try and look for the value, look for how we can help them, try and align with their objectives, and then be as honest as possible about where we can and can't help them with the things that they care about. And that's the key point, is if you don't address things that people care about, no matter how sexy your technology is, it's a waste of time. You're not actually serving them, and you're not serving yourselves.
Yeah, I totally agree. Actually, I just want to add something to that point as well. In terms of what they care about, we had to all go and we put our whole team on a behavioral economics course. And even just understanding something really simple as Maslow's hierarchy of needs. So when you could share to that marketing team that we could do things 90% better than they were currently doing, they didn't get excited by the fact that they could add more value. They got scared, and fear actually replaced that desire to increase adoption. They were just like, yeah, it adds value to the company, but what does that mean for me, right? And so it was important for us to really pay attention to, I think, what you were saying, Richard, but also when you talk about what they care about is whether it'll impact their job or not, or how they can work together with that. So, yeah.
I've got a question I think we're going to save to the end here, but there's one here about the use cases. Can you see anything else coming up in the horizon, Richard? Obviously, you've mentioned 5. Is there anything, do you think, that might come up in the next few years that people might start, using Graph to solve? Or you're on mute, Richard. Sorry. Yeah.
Yes, there you go. So very much so. And I think what I actually only talked about 4 for time purposes. But there's one which I was going to bring up is, first of all, is data systems now are getting so complicated that they need to eat their own dog food a little bit. And data quality is becoming an enormously important part of this. And so surprisingly, or maybe not so surprisingly, is that data systems aren't necessarily designed to actually measure themselves. They're more about measuring other things externally. And so I think that's going to be a big deal, is organizations, both within data processing, but also within the organization as a whole, are going to start introspecting themselves and measuring their own performance and using exactly the same techniques. And since it's a very large flow of information through a network of interacting components, graph databases are in a very good position to actually help with that. So that's where we come into it. So that's we talk about data lineage and data provenance, but actually from a value point of view is, how can I trust my data? Do I know my data is arrived in a timely way? Is it actually, does it have authority? Should I trust it? That sort of becomes very important at every scale. I think that's really important.
I think one massive use case right now with the virus and
yes,
contact tracing. It's huge. I mean, you know, the fact that graphs, nodes and edges, people connected to other people, potentially connected to other people, but more importantly, you can even predict who they're likely to be connected with or likely to be. Graph would be absolutely fantastic with that, you know, and also a bit more light touch than spying on exactly where you are and so forth. I think it's the graph would be less intrusive, but potentially give you really, really strong results. You know?
Yeah, and it's what we tend to call a graph shape problem. And I'm sure, as Martin was going to say, we actually have 2 nation scale COVID tracing apps doing exactly that on top of our software. And that's because it's so easy.
We have somebody doing exactly that, a government in West Africa, but we're not allowed to say who they are at the moment. Doing exactly that, they're using mobile phone data to track if somebody is confirmed as having COVID-19. They can see from their mobile data who they've been in close proximity to in the sort of, whatever the time period is, and then they could be sent messages to go and get checked for the test. We also have a very large COVID-19 tracking database in the US. So absolutely right. That kind of, and I think that's the point about what will be the next use cases. I think, without wanting to sound overly non-technical, if somebody's trying to solve a data problem and they're getting bogged down because it has a lot of joins, it's probably a good time to look at what the next big graph use case is going to be, because that's a very good clue that it's a graph shaped problem. Yeah, COVID-19 is a perfect example, and yeah, it's a sad use case, but it's a useful use case.
If you pick up the book called Connected by Nick Christakis, it's a bit of a pop science book, but he also does a great TED talk. There you'll just see hundreds and hundreds of potential use cases just open up out of that. He basically goes under the fundamental belief that we are a connected and social species. So,
and I think when we look at a use case as well, sometimes customers are locked into looking at their data, but we have customers in the manufacturing sector where the value that's created is by joining their data with their supplier data. So it's also important to look beyond the boundaries of the data that you have in-house. And I think that's part of the challenge, is being creative enough to ask questions that you didn't ask before, because it's the combining of different data sets also is a significant part of the value creation. But that's not something that people look at today, because the solution is very hard to do and it's difficult, so they go off and do something else. So looking outside of your own data is important.
Yes, indeed. And it's perhaps fitting that we ended with discussion of COVID, given what it's doing to us all at the moment and keeping us inside and stuff like that. So I'd like to take this opportunity to thank all the guests on today. I thought it was a really good discussion. Certainly one of my favourites so far. And thank you for the 2 presentations. Sorry for anybody whose question we couldn't get to. Please do get in touch over social, and we'll try and we'll try and get those answered. But from us here and from all the guests, have a very, very happy bank holiday weekend, and we look forward to seeing you again all very soon. All right. Thank you very much. See you later.
Thank you.
Thank you.